Hello guys, myself Dhruv Sakralia from LJ Institute of Engineering and Technology. I am here to explain about my project, the mini Hacksaw machine using the 4-bar chain mechanism. So first, what is the 4-bar chain mechanism? The 4-bar chain mechanism is a mechanical linkage consist of 4 bars or rigid links which are joined together using 4 pivot points or joints. The usual arrangement of the 4-bar chain mechanism is of rectangular or diamond shaped configuration in which one of the link act as an input link, other act as an output link, and remaining two link act as a coupling or connecting link. The 4-bar chain mechanism is commonly used in a wide range of mechanical devices such as engines, robots, machines, etc., where it is used to convert rotary motion to linear motion or vice versa. Due to its simple design, reliable operation, it makes better option for the engineers and designers who wants to convert motion in a precise and controlled manner. There are many inversions of the 4-bar chain mechanism which can be achieved by fixing different links of the 4-bar chain mechanism. I have used one of its inversion called the beam engine to achieve the back and forth motion of the hacksaw. So what is the beam engine? The beam engine is a type of reciprocating engine which was invented in earlier 18th century. So basically beam engine is used to convert rotary motion to the reciprocating motion. It consists of the overhanging beam which is fixed at its pivot point with one end connected to a piston via connecting rod, other end connected to a crankshaft which is used to transfer energy to the flywheel. The motion from the piston is transmitted to the beam via the help of connecting rods and links. I have replaced the piston with a disc cutter to make the hacksaw machine. Here are the components which I used to make this project. Let's see the components that I have used in this project. First, this is the disc which is connected with the 12-volt DC gear motor. Further, the disc is connected with the input link, and the input link is connected with the overhead beam. The overhead beam is fixed at its pivot point, and its other end is connected with the output link, and the output link is further connected with the disc cutter. Let's understand the working methodology of this project. A beam engine mechanism uses overhead beam to create motion. Here I have used a beam engine motion based assembly in order to achieve hacksaw cutting motion using circular cutting disc. This system uses a motorized disc to drive a connector which is in turn to and connected to an overhead beam. The overhead beam has a connecting rod in turn to a connected to a mini hacksaw blade. When the motorized disc is turned on, the connecting arm starts reciprocating the overhead beam. The beam now helps achieve a back and forth cutting motion as required by the hacksaw blade. I have also constructed a small bed in order to rest the workpiece to achieve the desired cutting. Thus we study the designing and fabrication of mini hacksaw using the beam engine mechanism. Overall working methodology using the beam engine is simple but effective way to cut any material by using this reciprocating motion generated by the concept of the beam engine. The hacksaw can make precise cut without requiring a lot of manual efforts from the operator. Here are the application of my project. The application of hacksaw using the beam engine mechanism is situated where large amount of cutting power is required, such as manufacturing or fabrication industry. The beam engine provide a reliable source of power to drive the hacksaw blade, making it easier and faster to cut through the material. Additionally, using the beam engine mechanism would reduce the physical efforts of the operator, making cutting process less tiring and more efficient. Overall application of the hacksaw using beam engine mechanism would be most suitable in the industrial setting where high degree of cutting force is required. Using these two tools can provide more reliable and efficient for cutting through the materials. Thank you for watching the video.